Welcome to The Explainer. Today, we're diving straight into a pretty wild economic cycle happening right now in AI-assisted software development, a trend a lot of folks are calling vibe coding. Think about it. Organizations are generating software incredibly fast these days. A person describes a feature, the system produces the code, and boom, a working result appears within hours. But then, almost immediately after, experienced engineers are being paid thousands of dollars to remove or rewrite that exact same code. It's a highly unusual cycle, and we're going to break down exactly why it's happening.
Okay, let's look at the agenda. First, the AI coding paradox. 2, local success, global burden. 3, the paid cleanup economy. 4, the continuous debt loop. And 5, the judgment layer. There's a phrase that perfectly captures the core irony of this situation. Cheap generation creates expensive judgment. You see, previously, the high cost and the sheer friction of implementing code acted like a natural filter. It forced teams to think really carefully before building anything. Today, AI has effectively dropped the marginal cost of generating code to zero. Production has become cheap and completely abundant. But as a direct result, human judgment, actually knowing what code should exist and what should be deleted, remains incredibly scarce and therefore very expensive.
And that leads us to this bizarre structural shift in the economics of software. First, organizations pay for AI tools to produce code at breakneck speeds. Then, when the codebase inevitably becomes too bloated and complex to manage, they turn around and pay human experts to identify which parts of that AI-generated code should never have been produced in the first place. Now, the cleanup process itself might use AI, sure, but only under the strictest human control.
Section 1. The AI coding paradox. From implementation to judgment scarcity. Now, what's really fascinating here is what happens when that traditional coding friction disappears. A huge disconnect emerges between local task success and total, long-term system value. An AI coding agent is evaluated on task success. It basically just asks, hey, did the payment feature work? But a complete, healthy software system has to ask a much broader set of questions. What maintenance burden was just created? What new risks were introduced? Did this quick fix destroy our future options? Speed is so frequently mistaken for true capability.
Which brings us to a critical reframe of a familiar concept, technical debt. We really need to stop thinking of it as just bad programming. Technical debt is actually a transfer of cost across time and across people. You gain immediate benefits today, right? But a future maintainer absorbs all that complexity, and an operations team absorbs the reliability risks somewhere down the road.
Section 2. Local success, global burden. The hidden cost of vibe coding.
Because generation is so cheap, features are getting built way before their strategic value is even clear, and this leads to structural accumulation. Duplicated logic starts popping up for similar tasks. Dependencies grow completely unchecked, security exposure increases, and the whole architecture just loses its flexibility. Temporary fixes suddenly become permanent, and organizations start accepting code that nobody fully understands. The software might appear perfectly functional to the end user, but underneath, it's becoming globally incoherent.
Section 3. The paid cleanup economy. Human-guided repair. Unsurprisingly, the market is already reacting to this architectural burden with a brand new sector. Take a service like SlopFix, for instance. Reports show they're charging up to $10,000 a week just to inspect and slim down AI-generated code bases. They do use AI agents to help with the heavy lifting, but those agents are kept on a very short leash, under intense, expert human supervision.
Because, well, deleting code is the easy part. Deciding exactly what can be safely removed without breaking the system, that is incredibly difficult. Is a block of code truly unnecessary? Is it duplicated logic? Or is it actually defensive code that's preserving a security boundary or protecting future flexibility? It might be a tightly coupled structure that's just a nightmare to untangle. Human experts command these premium rates because their judgment is what actually defines what matters.
Section 4. The continuous debt loop. The 6-stage life cycle.
And this brilliantly illustrates the real limitation of the paid cleanup economy. It only acts after the problems have already accumulated. Look at the life cycle. A user writes a prompt, AI rapidly generates code, and you get a working prototype. But structural debt accumulates right alongside it. Then experts are brought in for a paid cleanup, which gives you a temporary recovery. But if the underlying generation process hasn't changed, the cycle just loops and repeats itself.
So that leaves us with a pretty massive question. If the method of generating code with AI remains exactly the same, how do we actually govern what gets added in the first place?
To break this cycle, we have to find a way to intercept technical debt before it permanently enters the codebase and forces another expensive cleanup.
Section 5. The judgment layer, the energetic paradigm.
The structural solution here requires moving entirely beyond retrospective repair. Enter what's called an energetic paradigm. This is a control architecture that treats software not just as static text files, but as a dynamic, living system. It means every single code change is governed as a redistribution of constrained capacities. We're talking resources, risks, dependencies, and future possibilities.
This paradigm introduces 3 distinct layers to the software lifecycle. You have vibe coding, which optimizes for the current request to get code out quickly. Then you have human-guided cleanup, which repairs the accumulated damage. But the third layer, the energetic paradigm, acts as a persistent judgment layer. Its entire focus is proactive governance, evaluating changes before they are ever accepted.
A true control layer shifts the optimization target away from individual, isolated prompts and aims it at the long-term system trajectory. Before it accepts any generated code, it asks the hard questions. Does this duplicate existing capabilities? What new dependencies are we increasing? What future costs are we creating right now? Does this reduce our overall flexibility? And crucially, is this change even reversible if our expectations turn out to be wrong?
Let's see how this builds out into a continuous control loop. Step 1 is aligning the user's intent with the actual objectives of the institution. You can't just start generating. You have to reconstruct the true state of the system first. That means deeply understanding your data ownership, your security boundaries, and your operational paths before a single line of new code is written.
Moving right along to step 2. Once that system state is actually understood, the control layer doesn't just settle for the first AI solution. It generates multiple candidate actions, alternative paths, and each one of those is evaluated under global, long-horizon judgment to figure out which path consumes the absolute least total capacity while still delivering the necessary value.
Finally, step 3 is ensuring bounded execution. Any high-impact changes have to operate strictly within explicit boundaries, and honestly, they often still require human approval. This is paired with multi-level verification to guarantee the system maintains structural and operational continuity over time. You simply cannot allow an efficient, short-term AI solution to permanently wreck your long-term flexibility.
So, pulling this all together, keeping a calm, analytical perspective, the central lesson here is quite simple. The issue is not that AI always writes poor code. That's just not true. The core problem is that our ability to generate software is accelerating exponentially, and it is growing far, far faster than our structural ability to judge, filter, and manage it.
Paying for human-guided cleanup certainly has its value, for sure. But remember, cleanup only reduces yesterday's excess. Establishing preventive governance through a persistent judgment layer, that is how an organization actually controls tomorrow's accumulation.
As rapid, vibe-style code generation becomes the absolute industry standard, every team faces a choice. Will your organization just accept the continuous debt loop and keep paying a premium to delete code? Or will you take control and build the missing judgment layer? Thanks for joining this explainer. It's definitely something to think about as you look at your own systems.